Alright guys, I think it's about time and let's get started. I'm very excited to meet our old and new friends here today. I can see you in the attendees list. I know you're from all over the world, including Asia Pac, Japan, Korea, Europe, North, South America. Wherever you are, whatever your time zone is, first of all, good morning, good afternoon, and good evening. I'd like to welcome you all to this webinar today on the Voxeldance Additive 4.0. As we will be recording this today, so if you could put your phones or PCs on mute, I'll appreciate it. Here's the agenda for today. We will spend 5 to 10 minutes to give an overview of our company, product, and specifications. Then a good 30 to 40 minutes on today's main topic, what's new in the Voxeldance Additive 4.0 release. I'll do this by a 10-minute presentation and a 30-minute demo. The last part would be the Q&A and the key takeaways for all attendees. If you have any questions during the webinar, please use the chat and our staff will answer you in real time. While if unable to answer certain questions, we will reach out to you after this call to follow up. Okay, now let's get started. In the next hour, I'll give an overview of the latest Voxeldance Additive 4.0 and a demo session on some of the key features introduced in this 4.0 release. The contents will be more technical than commercial, so for those of you who are familiar with Voxeldance products already or other competitors' products, I believe this is going to be an exciting and informative webinar. For people who are new to Voxeldance, first of all, hello and love you all. Secondly, don't worry, during this call, you can have a feeling of the level and quality of product we have been making so far, and feel free to contact us or our partners after this meeting if you feel interested. Now let's begin. First of all, who are we? We are a software company with a group of young and passionate, talented people dedicated to software solutions for the additive manufacturing industry. The R&D team has great knowledge and experience of both the software coding in terms of computer graphics and the additive manufacturing technology itself. Every company has its value. Our value is listening to customers and keep delivering better solutions to help every user improve productivity and hopefully this industry to evolve. We have solutions for both industrial applications and the consumer market. Voxeldance Additive is our flagship product that covers all the mainstream vertical applications and printing technologies. As you can see on the screen, these are the two major products from Voxeldance now. So the Voxeldance Additive is for industrial applications, and Voxeldance Tango is a consumer market product with lots of LCD and DLP users crazy for it. They both are the data preparation software. Someone may call it CAM or slicer. I understand lots of our attendees today are experts in this industry, but still a little bit explanation on the concept CAM. So the CAM acts as a bridge between the files of 3D design and the actual printer. So you cannot simply take an STL file to the printer and immediately print it out. It requires a series of editing beforehand to the original file until it can be 3D printed. This is what our software do. A professional software can influence the final print in terms of success rate, material consumption, printing quality, whether it's easy to post-process or not. There are only so many options on the market, including Voxeldance and maybe one or two others. You know their name, right? And I'm glad we seem to be doing great so far in getting rapid growth of the market share year over year. But again, this is what our product do to prepare the data and oftentimes complicated and challenging models so it becomes ready for printing. Now, here in this slide is an overview of the workflow, or the collections of functions available on the Voxeldance Additive. Create platform, import STL or CAD file, model fixing, editing, orientation and nesting, and of course, support generation, either automatically or manually, or mix and matching them, and lastly, analyze the model and slice it. We also have an option which the OEM manufacturers might be very interested the hatching function. This is an optional module. We call it BP, the build processor, that can be purchased and integrated into the Voxeldance Additive. It basically prepares the slices with laser hatches so the printer, usually SLS and SLM printer, can read the file and start printing according to the laser lines suggested by Voxeldance. It's kind of similar to the concept of G-code in the FDM world. So that's Voxeldance Additive, all about data preparation and an option for laser hatching. Now, here we are, the topic for today. What's new in the latest Voxeldance Additive 4.0 release? First on this slide, a summary of all the key upgrades compared to last year's 3.0. There are major upgrades on key features like shrink wrap, a highly efficient fixing tool, especially for service bureaus. 2.5 dimensional nesting is an evolvement from the traditional 2D arrangement, especially for dental preparation. We also added new types of support structure, such as tree support and web support, according to our users' feedbacks. And also a major upgrade on the build processor that gives granular settings for our OEM manufacturer partners. The R&D team also put great effort into improving the algorithm, which you may not find it on the toolbar, but as a result, increased the overall performance and of course, less crashes and issues. I'll walk you through these new features one by one in the next few slides. First of all, UI and UX. It's all about user experience. I know it may look trivial to you, but it also shows the fact that our users have been frequently using the product and they start to expect the workflow to become more simple now. Especially the 3D printing factory or the service bureaus. They gave us great suggestions on features that could make their life easier during daily printing works. In previous versions of Voxeldance Additive, you can save your job as project, but it only allows you to save them all. In Voxeldance Additive 4.0, you can work on multiple platforms, each with different sets of models, and then save, export, or print individually. The concept is somewhat like artboard or worksheet in other softwares. In real life, a service bureau may have different orders coming with different sets of models to be printed. In such case, this improvement can help them better organize the jobs and speed up the process. Here's another improvement on the daily routine of users from service bureaus. The user can quickly switch between a list of parts to be edited, like support generation, labeling, etc. All the keyboard shortcuts are customizable in Voxeldance Additive. Some of our users require improvements on the camera rotation. Sometimes when they rotate, because the center of the camera is in fact the center of the screen instead of the model they've been working on, the camera went crazy like all over the places. And from Voxeldance Additive 4.0, you can define your camera rotation center whenever needed by holding down the right button of your mouse, and then the position of the cursor will become a temporary rotation center. So it's kind of handy. So here's the end of UI UX. In next few slides, we will start to cover more technical improvements. First is the feature that we use to edit the models. Surface to solid. This feature can add a certain offset to a surface. You can make it thicker in both directions or only one direction. Sometimes you might have to work with just surfaces. Instead of going back to the original CAD design, you can use this tool to create a printable solid out of an existing surface. Or sometimes you want to use Boolean operation that involves a surface and a solid. In this case, you may want to make the surface thicker to avoid errors after the Boolean. Shrink wrap is another major new feature in 4.0, which I know it's going to be frequently used. Basically what it does is to wrap a layer, and oftentimes very thin layer, around the original model. As you know, in real life, some models are a total mess that are almost impossible to fix. Imagine a car model, like on this page, or an architectural model with tons of errors. Shrink wrap is an easy way out. So it covers a surface around your model and shrink around it, like a plastic wrap you use in the kitchen. The errors are also gone. Mesh smooth is another useful feature. Some people refer to it as denoising, filtering, or fairing. So data in additive manufacturing world may have noisy mesh. A typical example is the scan data. As the name suggests, you can filter out the noise on the input data and make the mesh smooth. So for shrink wrap and mesh smooth, we will show you how they work in the demo session. Next is arrange, or you may call it nesting. Voxeldance Additive has 2D and 3D nesting. We made a series of improvements on the nesting algorithm. This is one example. Unlike previous versions, in 4.0, when you do 2D nesting, the software will consider not only the outer shape but also the inner shape of the models on the platform, especially the ring-shaped models. The space inside the ring will also be used for nesting, as long as the models can fit in. 2.5D nesting is an enhanced 2D nesting. So not only did it arrange the models on the platform and spread it out in the 2D dimension, it also considers the z-axis to see if any chance they can get even closer. The dental RPD is a typical use case where all the RPDs shaped like same but curved walls can be arranged more tightly. So imagine how you arrange the dishes and bowls in the dishwasher in your kitchen. If looking from top angle, these models are colliding into each other, but if peeking from side, these tilted RPDs are not touching each other at all. Next is probably the biggest feature set in any data preparation software, which is the support generation. Let's begin with the two new support types. First is tree support. It's essentially a variation from the existing bar support. It works great in dental and jewelry applications, for example, and it saves materials. You will see more details in the demo session. Next new support type is web support. It works great with ring-shaped models. So these models don't necessarily have to be a perfect ring. As long as there's a surface with a hole in the center, the radial structure of web support can deal with the shrinkage of such shape very well. You will see the demo as well. And here's border reinforcement. It is a new feature inside the volume support settings. So in metal printing, well, in fact also SLA, the volume support works great with larger parts. However, it tends to crack at the edges that connect to the base. Border reinforcement will add something like a chamfer on the edge that can hold the part steady with stronger support. Teeth intersection is a new feature or option inside the volume support settings. It simplifies the shape of the support top tips. As you can see on the picture, it makes sense in the metal printing particularly. Once you slice the model, the support tip after the teeth intersection applied will be shaped like a cross with two intersecting lines. The idea is the laser of metal printers will only have to scan 2 times for each support tip, which saves time as compared to 4. I will give more details in the demo as well. And lowest point or lowest line support. This has been one of the key features with Voxeldance Additive for years. Not only will they hold the model to its position like a support, in metal printing scenarios, lowest point or lowest line support are very important as they can transmit the heat from the model to the base to avoid deformation. So in 4.0, we give more support types that you can choose from to become the lowest support, including cross support, bar support, and smart support. In Voxeldance Additive, we also allow users to modify the generated supports. In 4.0, we give even more freedom to our users. For example, you can drag and drop the support structure to avoid the bottom tip to grow on surface of the model. You can also edit the tip of the tree support or smart support. You will see the demo in a minute. Last but not least, slice and hatching. This is more of an OEM manufacturer-oriented function, so I'll fast forward. First of all, we completely redesigned the build processor in BP 4.0. Now supports multi-laser and a wide range of new granular settings. Talking about granular settings, You can apply different settings to areas like downskin, inskin, and upskin. They are displayed in different colors in slice view mode. The blocked path is essentially an improved way of running the laser in scene walls. Special volume is one big upgrade in the build processor. You can mark different parts on a model and apply different laser scanning strategies to them. You will see what it does and how it works in the demo session. This model on the picture, for example, is an impeller. We will apply different BP scripts to the vanes and the rest of the impeller. Voxeldance Additive has had a slice viewer that users can easily check the hatching details. In 4.0, we provided a dedicated function, BP Hatch Viewer, so you can quickly access more key information from one page. I'll demonstrate both Special Volume and Hatch Viewer in the demo. Okay, so this is the end of the presentation. Take a deep breath and I'll move on to the demo session. Now, here's the first demo for the new feature called Shrink Wrap. Let's first import a file, which is dental crown. Now here's a tip. You may want to always display the part border. With this option turned on, it's easy to locate the errors such as bad edges or intersections with your bare eyes. They are always displayed in yellow or red color on the model. As we all know, the errors like bad edges and bad orientation may lead to print fails. Therefore, you always want to fix them before further steps. In most cases, you may use the automatic fix. And you know what? It works in many cases. Unfortunately, in this case, the result after autofix is clearly unacceptable. Now, I'll explain why. Let's undo and further investigate the part. In real life, such file was likely made in previous step by softwares like Cambridge or 3Shape. Let's first convert the shell to parts. You can now see the 3 T's independently and they all look fine. But the surfaces that connected these 3 T's obviously have some tricky errors. It's twisted almost like a Mobius ring. That's why it's super challenging for any software to identify plus autofix such errors. Also, for those familiar with CAD design softwares, you should understand that if you simply sweep the spline, you will likely get awkward results, right? Now, one of the best solutions to such scenario is to use the shrink wrap function, and it's available on the latest Voxeldance Additive 4.0. Let's set both the tolerance and the thickness to their minimum values. Click OK, and the shrink wrap is done. Well, sometimes you may still find errors like this, which are in fact sharp triangles. You can simply go ahead fixing them by deleting sharp triangles. Now the file looks smooth and clean. It is properly fixed. Next, we need to add support to it. Voxeldance Additive offers a wide range of support generation and editing tools. You can add support automatically, manually, or mix-match both ways. Next, I'll do the manual support generation only for demo purpose. Let's enter the support module. First, preview the support area. You can hide this pop-up window if it's annoying. We have customized a volume support template before this demo. Let's select it and set as default. Now, whenever you want to add volume support, manually, this specific volume support template will always come into play and ready to be added. Now, you can start painting. Use the mouse to mark the outer contour of the tools by adding anchor points, and apply. You will now get a volume support on the areas just painted. You may want to use the volume support for this model because the shrinkage stress of dental crown is usually larger than RPDs. But there's room to improve the support in order for easier printing and post-processing. We will change the value of the fragmentation here to split the support structure into shapes like crosses, which also looks a little bit like point support. If you turn the model into transparent, you will find the support structure looks like crosses but split open. I'll illustrate with current parameters what it will look like after slicing. The support structure will become 4 lines or vectors in 2D slices. In Voxeldance Additive 4.0, you can select teeth intersections to further improve it. Now, you will find the support structure becomes crosses, and therefore, in each slice, it becomes 2 vectors crossing each other. By decreasing 4 to 2 vectors, it significantly improves the productivity with simplified laser scanning. But please remember, it's always recommended to test the support before massive printing whenever you make such changes to the support parameters. Now that's it for the first demo. Next, I'll demonstrate the Mesh Smooth function in the Voxeldance Additive 4.0. Here is a bridge-structured hotel. Let's hide the platform first. You may notice this model is a result after topology optimization. For those who aren't familiar with TO, topology optimization is a mathematical method that optimizes material layout within a given design space for a given set of loads, boundary conditions, and constraints with the goal of maximizing performance of the system. And it uses a finite element method, aka FEM, to evaluate the design performance. And this model itself is the result after topology optimization. From Voxeldance Additive 4.0, there's a new feature called Mesh Smooth in the Modify module. Select the model, click Mesh Smooth, and keep the value of the strands to 1. And click Apply, you will find the model becomes more smooth now. For such model, in this case, we want to do the Mesh Smooth for 3 times. Now it's nearly done. Like in the first demo, there might still remain some tiny little errors like these cracked lines on the model. Let's use shrink wrap to improve it. Set tolerance to 0.1 and thickness to 0.25. Then click OK. It will take some more minutes. While we are waiting, I'll move on to the third demo on the tree support. Let me import a new file and show you how it works on a jewelry, in this case, a ring. To add support automatically, we usually do this by running a support script, like this. Here's the result of an automatic tree support script. But once again, I'll show you how to add tree support manually for demo purpose. Let's enter support module and remove the previous support first. Click support area, and the hot zones are the ones with critical angles larger than 45. Click Add Bar Supports. Scroll down on the left and you will find a new set of parameters called Branch in the bar support template. If you set to any value larger than 1, the bar support will become a tree support. Now, click on the surface of the model to add anchor points, and you'll eventually form a tree support on the model. You can also add more branches. First, click Add Tree Branches. Then click on the surface of the model, then find a place on the trunk of the support to complete this job. Also, if you hold Shift button and then click on surface of the model, you can quickly add more branches. In this case, you don't need to specifically find the anchor point on the trunk. The software will automatically decide the point on the neck of the model for you. Now, what if I want to add support to the inner ring? Let's repeat the steps, and here's the result. Now I know you may not want the bottom of the support to ever touch the model because it's really unfriendly for post-processing. In this case, you can move the anchor point. Select the support. A gizmo will show up. Hold Shift button, drag and drop the XY plane. The support will be moved and grow on the bottom of the platform instead of the bottom of the inner ring. Also, the angle looks awkward here. We can also drag and turn it into a better angle. That's it for a quick demo on the tree support. Let's save and exit. Now, back to the previous window. The shrink wrap on the bridge structure is done. With the 0.25mm thickness added, I guess you can tell the difference if I undo and redo. See how the two lines here, they would disappear after shrink wrap. So here's the end of the two demos of Mesh Smooth and Tree Support. And we are halfway through. And here's the last part of the demo. It will be done on this model, which is a pump impeller. I guess you may have found it in our 4.0 newsletter or banner on the website. We will be doing a number of preparation works on it, such as orientation and support generation with the latest 4.0. Let's first check the dimension. The diameter of the impeller is 147. As you can see on this impeller, we got two plates in parallel, which is obviously challenging for 3D printing. So we will have to do something until it becomes easy to print. First, let me rotate by 45 degrees and lift up a little bit. We all know that generally speaking, 45 degrees is the critical angle for most SLM prints. Next step, I'll offset the model by a little, which can be cut off during the post-processing by CNC machining. Let me first mark the side of the outer ring. Use local offset and add triangles by 2.5mm. Click Apply and it has grown outwards by 2.5mm. Next, let's enter the support module, and I'll demonstrate real quick on how to grow a tree support. First, I'll generate tree support on the edge of this model. Let me first mark the edge of the surface. Well, since it takes some time, so I will load a new project of the exact same model, but I've already marked the edge and save as support area. Then apply a support script of tree support to this support area. And it's automatically generated. Because this model was rotated by 45 degrees, the supports are lower on this side and higher on the other side. Higher supports tend to be unstable, so you may want to strengthen the support structure by adding cross connections between the bars. Enable bar cross connection, set cross type as border method and connection type as alternate. Also, we probably don't need to worry about the lower height, so we can set this value to 15, for example, and click Generate. Now you can see the connections are added and they aren't growing lower than 15mm. That's it for the tree support on the edge. And I'll move on to add volume support to the rest of this model to allow heat transmission and avoid deformation. First, mark the surface. find a pre-configured volume support script and change the parameters a little bit. We will do a border reinforcement. The direction is outwards. Change the values of reach, max height, and spacing. And the volume support is generated. And this is the result of border reinforcement, and also the end of the work of this model. I'll start another demo with this smaller impeller. Again, I'll explain a little bit before the demo. This impeller is essentially a ring-shaped model. The point is, when you print something long like a box or cylinder, the shrinkage stress will likely go this way, and the longer side has bigger shrinkage stress. A wall pitch is more likely happen, while if it's a ring, the shrinkage stress would be like a spider web. Therefore, a web support is ideal for a ring-shaped model. Now back to the VDA. Select Support Module, mark the surface, create a support area, and apply web support. The support looks just like a spider web, distributed outwards from the center. And I think we also need some supports on the edge. Now the tricky part is the model has no edge that I can easily mark. In this case, we can copy the previous support area and do it by adding volume support. Let's change the parameters first. I'll reinforce the contour by increasing the thickness to 0.2. The purpose of this volume support is only the contour. Therefore, we don't need infill. And a final touch by enabling a border reinforcement. Done. Here's the volume support with only the contour. Zoom in and you can see the contour has thickness. This is border reinforcement. It will not add thickness. Not only the outer ring, this inner ring, though very small, also has border reinforcement. We have some clients complaining that with some other software products, the thickened contour looks awful, as the mesh and triangles sometimes would mess up. But you can see it all looks neat and tidy with Voxeldance Additive 4.0. Now, let me unhide both the web support and the volume support. And that's the end of support generation on this small impeller. Now we are at our last demo. I'll show you how to use the special volume. This is new feature of Voxeldance Build Processor. In addition to the Voxeldance Additive, which is the data preparation software, we also have a product called Build Processor. It does laser hatching on each slice file and export the hatch file for the printer to use. If you and your client is OEM manufacturer, a little development is needed to let the printer understand our hatch file. Now in older versions, on one model, we only allow one build script for it. While in next demo, I'll show you how to use special volume to apply different build scripts to different parts of the model. First, like the logic behind support areas, you need to mark the special parts on the model. Make them the special build area. In this case, we call it special volume, and then apply certain build scripts to it. For this demo, I plan to do this to all the vanes on this impeller. Let's mark all the veins. When marking the veins, the ring on the bottom will also be accidentally marked, which I don't want it. Let me unmark this area. Hold Shift button, drag and unselect. Now I get the result of only the veins being marked. Then I'll duplicate the marked triangles so I get a new set of identical veins. Hide the original model. Now don't be confused. These duplicated veins will later on be converted into special volume or special area. I will eventually apply a dedicated build script to this special volume, and that's the purpose of it. So the duplicated veins will not become part of the model. Just wait and see. Let us first fix these veins. And add a little thickness with shrink wrap. Shrink wrap here is not for fixing, but to redesign the veins to make the special volume slightly larger so it can cover all the actual veins. Set tolerance to 0.1 and thickness to 0.25. Done. You can see that after shrink wrap, the duplicated veins look larger than their original ones. Just remember, we did it on purpose. Now we can configure a new build script to areas that are covered by these slightly larger duplicated veins. Select it from the list and enter Slice module. Now this is important. Set it as a special volume. Once done, a suffix called special volume will be added and the color changed to orange. So these duplicated veins will only be a special volume, not an actual model. This is not printable. It only kicks in when the software needs to do laser hatching. It will apply different build script to the parts covered by this special volume. Select both items. Let's create build file. Choose the right machine and material, then take a look at the build script. We have calibrated a set of parameters that prove to be working nicely. There are two build scripts. One for solid part. The hatching style is set to stripe fill. And the other one for thin walls, which uses offset fill to do the hatching. Once parameters are edited and confirmed, I will assign them to the part. So for the majority part of the impeller, I will use solid. But for the special volume we just created, which is meant to be the veins, I will use thin wall. Save and close, then OK. Here are the slices with laser hatch. This is the first layer. Scroll up and down to preview each layer. Enable Show Directions to view the directions of laser. Let's scroll up until we can check the slices of veins. The area within this orange circle is the special volume area. Now you can see the majority of the part is using stripe fill, while the areas fall in special volume are using offset fill. Alright, that's all for today's demonstration on Voxeldance Additive 4.0. If you are interested in this new version, please visit our website and apply for trial. Thank you.